Today we're going to be going over lesson 3.3, exploring angle measures, and it starts off with our math message, which is how might you use this figure to prove that the measure of each angle of a square is 90 degrees. Be prepared to explain your answer. So as we look at this problem, we have the circle and we have four squares. Corner for a square, corner, corner, corner. How can you use this circle to prove that each corner of a square is 90 degrees? It's a right angle, which that square shows us it's a right angle. Go ahead and think about that. And when you're ready with your answer, come. So how does this problem work? How can you use a circle to explain your answer? Well, in a circle is 360 degrees. If you go all the way around the circle, it's 360 degrees. Like if you did a slam dunk and you turned around once, or if you did something on a skateboard or a snowboard where you turned around once, it's called the 360. So 360 degrees to go all the way around a circle. There are four angles within that circle. So to prove that these are 90-degree angles, we can think 360 degrees divided by 4, which equals 90 degrees. 9 times 4 is 36, so 90 times 4 would be 360. So that's how we get the answer for proving that the corner of a square is 90 degrees. Moving on to the next page, let's look at a couple more problems here where we can think about figuring out the measure of the angles of polygons by drawing a circle using this 360 degrees. So on this problem here, we've got 6 triangles together, and we want to know what each of the angles in a triangle is going to be. So if we look at this right here, these angles, what are those angles worth? What is a measure of those angles? Using the circle, we know the circle is 360 degrees, and we know that there are 6 triangle corners that are together. So for this, we could just take 360 divided by 6, which equals 60. So we know that 360 degrees divided into 6 groups would be 60 degrees for each. So the measure of the angle of this triangle is 60 degrees. Now let's come over to our hexagons. We have 3 of those together. We'll draw a circle around here. Oops. I don't know what's going on with that. Let's see if we can. That was crazy. Let's try that again. So there, we've got our circle, and we're looking at what is the measure of each of these angles. They're all the same. There's 3 of them. The circle is 360 degrees, so in your head, what are we going to have to do for this one? We're going to take those 360 degrees and we're going to divide it by 3, because there's 3 angles that make up that 360 degrees. 360 divided by 3 is 120 degrees. 360 degrees divided by 3 is 120. And doing that in your head, you can think 12 times 3 is 36. So 100 times 3 would be 360. Another way to do this is by using a straight line. And I'm going to get up my straight line maker here, and we're going to go with this green color. With this problem, we have, going back to the squares, now we already know that the square is 90 degrees based on the math message that we did. However, let's use an example with a straight line. A straight line has a value of 180 degrees. Has a value of 180 degrees. So in this case, we have two angles that make up that 180 degrees. So we're going to take 180 divided by 2, which would equal 90 degrees. We can do the same thing on this problem, but this one, I'm changing it up just a little bit. So here's our straight line, and we're going to, based on the problem from this page, we know that the measure of a triangle is 60 degrees. Of these triangles is 60 degrees, but we're going to imagine that we don't remember that we don't know that. And this problem is a little bit different because here's our angles here. Those are different angles. Those are not the same. We know this is 180 degrees. There's two angles, but how are we going to figure out which is which? And to do that, we're going to grab this other triangle right here, and I'm going to say, well, this looks like this could cover this triangle here, and this triangle can go right here. So these two triangles can equal the angle that is right here. So now we can start and we can go 180 degrees, straight line 180 degrees, divided by 3 equals 60 degrees. But that only tells us the measure of this angle right here. The measure of this one would be 60 degrees. It doesn't tell us what this one is. So to figure that out, let's move these triangles. We know that these triangles make up this area here. So the measure of this angle is 60 degrees, and the measure of this angle is 60 degrees. So if we put those two together, 60 degrees plus 60 degrees is 120 degrees. So that lets us know that the measure of this angle is 120 degrees. And to prove that, we can add it up. 120 degrees plus 60 degrees equals 180 degrees. So we can use circle, we can use a straight line, and now we're going to look at one other way to figure this out. And we're going to use other shapes to find angles with our pattern blocks here. And we've already determined some angles. Again, we're going to imagine that we don't remember those at all. And we're going to start with a shape where we know the angles. And we're going to start this square. We know that the measure of the angle in a square is 90. But the other ones maybe we're not sure of. So we're going to use other shapes to help us determine the angles. We know this is 90 degrees. And I'm going to see if there's anything that I can do here with these other shapes to equal this angle right here. And the first thing I'm going to do is I'm going to start with this triangle. Now what could I put here that would help me know that this, or help us figure out the angles of all the rest of these shapes. And it looks like if I grab this one and put it there, this rhombus, that rhombus fills in the rest of that square. Now, from here, where can I go? Because just like we did on the last page, it's 180. We know that these two together are 90, but maybe we're not quite sure what the measure of this angle is here and the angle of this triangle. So I'm going to bring up another rhombus. Let's do this. I'm going to turn it just a little bit. So 1, 2, and let's do one more. No, it's not quite perfect, but this, as you can see, there's 3 angles here that make up, or three corners of the rhombus make up the 90 degrees. So that gets us back to, well, if we know it's 90, there's 90 degrees in the corner of a square, in the angle of a square, and there's 3 rhombuses that make up that. So we go 90 divided by 3, which is 30. So that's 30 degrees. Each angle of this rhombus is 30 degrees of the acute angles, we'll say. Now, how do we, if we know if we know this measure is 30 degrees, and 2 of these make up the triangle, that means that the angle in the triangle is 60 degrees. Again, this one's 30, and this one's 90. Knowing these 3, we can figure out the measure of the angle of all the rest of these polygons over here. So let's get rid of some of these. And let's bring out this trapezoid. How can we figure out what is the measure of the angle of these trapezoids? It's 2 different angles. And I'm going to start with this triangle here. So I can get one triangle here, which shows that the measure of this angle right here, this measure is 60 degrees. This one, not quite sure yet, so I'm going to pull in another shape. I'm going to pull in another triangle. And 2 triangles make up that. So if this is 60 and this is 60, 60 and 60 is 120 degrees for the measure of that angle. Okay, now let's bring out this. Let's bring out this rhombus, and I want to know what the measure of this angle is and what this angle is. And if I look, let me bring this so you can see it. That fits exactly with this. So this measure is 60 degrees, and this measure here is 120 degrees. We'll bring out one more here. We'll bring out the hexagon, and all of these angles are the same. We could use a bunch of different ones. We could use a square in another one. We could use this. We could use a variety of them. But I'm going to use the trapezoid because it looks like two trapezoids together equal the hexagon. And that is the case. So we're looking at this measure here, and the trapezoid fits there. This measure in a trapezoid is 120 degrees. So that tells us that each measure or each angle of this hexagon is 120 degrees. That doesn't mean that the angle of every hexagon is 120 degrees, or the same thing with any of these shapes. Just these particular pattern blocks, those are the measure of the angle. Two other examples I'm going to show you right now. Let's start with this one right here, and for this one we're going to use a straight line. Sorry for the pause there, it got a little loud in the classroom next door. Going back to this problem, we're going to be looking at this one right here, and we're going to go with a straight line again. The straight line is 180 degrees. There are 1, 2, 3, 4, 5 angles in that 180 degrees. So we're going to go 180 divided by 5 equals, and we'll pull up our calculator here. $180 divided by 5 equals 36. So each of these angles is 36 degrees. How could we use that to help us figure out what these angles would be? We know that in a triangle there are 180 degrees minus the 36 degrees in this angle. So that means there are 144 degrees left. We have to divide that by 2 because there's 2 more angles. 144 divided by 2 is 72 degrees. The angle here is 72 degrees, and 36 degrees. Now, using this as a straight line, how could we determine what this angle is and what this angle is? Starting with our square, we know that a square has a right angle which is 90 degrees. Our straight line divided that square in half. So we only have half of an angle here, half of a right angle here, which is 45 degrees, because 90 divided by 2 is 45. We still need to determine what this angle is. Straight line is 180. We can take away the 45. Oops, what happened there? 7, 10 minus 5 is 5. So that means 135 degrees. So the angle of this octagon is 135 degrees. So those are two other examples that you can use when you're doing these problems.